In this video, we're going to explore linear regression. Now, before we actually can talk about linear regression, we need to talk about where the pieces come from. Often, we're going to be given points using our scatter plot. And what we're looking at when we're talking about linear regression are residuals. And residuals is the difference between the predicted value that we may have from a given line with our x that we're given and what is actually found. And if you look at this graph, here would be a line, and here would be our predicted, the x with the predicted y. And there's this difference between what was actually found. Now, what we do is we find the sum of the squares of all these differences. That's what we have here at the sum of squares. And what a regression line does is it moves around until we find the smallest value for the sum of squares, because that means the differences overall are the least among all the different residuals, or each of these actual points versus their predicted points. So if we want to find the equation of a regression line, first we know that the equation is y hat equals mx plus b, where y hat is the predicted y value for a given x value. Because remember, x is always our independent variable. We're going to use Excel to help us with this. The first thing we have to do is we need to create our data, put our data into Excel and create the scatter plot. And remember to label those axes. Once the data in the scatter plot are created, we're going to right click on a point on the graph. From there, you'll get an option to add a trend line, and you click on that, and then within your options you want to make sure to have linear checked, display the equation on the chart checked, and the r squared value to be checked. This will put the regression line on the equation, and it will also give you the r squared value. But remember, the correlation coefficient is r, so we have to take the square root of that value to get our correlation coefficient. Say we have this data here and we want to find the regression line for height and weight and the correlation coefficient. First thing I do is I'm going to take my data and create a scatter plot. Next, I'll right click on any of these points, and it's going to give me this option. And down here is add trend line. I go through, I make sure that linear is checked and that I have the two buttons for equation and for r squared checked, and those will show up on the graph. So now I know that my regression line is y hat equals 4.11x minus 108.13x. Now I want to find my correlation coefficient. I know that I'm going to take my r squared and take the square root of that value, and that gives me 0.7835. Now this information, especially my regression line, I can use to help me predict information as I'm going forward. So say that I want to know how much would you expect a man to weigh if he was 7 foot 3 inches tall. Well, my equations, if I go back to my formula, the height was always in inches, so the first thing I'd want to do is put that into inches, and I'd get that that's 87 inches, because that's 7 feet times 12 inches plus 3 inches. Now I'm going to plug it directly into my regression equation, and I simplify and I'd get 249.44, so that tells me that I would expect a man who's 7 foot 3 inches to weigh about 249 4/4 pounds. Another thing I could ask is, John's 6 foot 5 and weighs 260 pounds. And I don't know, does the regression model accurately predict, or does it under or over predict his weight? Well, the first thing I'd want to do is first figure out what does the regression equation predict his weight to be. So I plug in the 6'5" into my x, so I have to first change it into inches, and I get 77 inches. Plug it into my regression equation, and I get that they predict his weight should be 208 pounds and 34 pounds. Now if I look, 208 is much smaller than 260. So in this case, the model predicts he'd weigh 208.34 pounds, but since he weighs 260 pounds, the model is under predicting his weight.